In this video, we're going to talk about the difference between parallel and perpendicular lines and practice writing linear equations based on parallel and perpendicular lines. So first, we note that parallel lines are lines that never intersect. So lines that never intersect. And again, intersect means that they must at least share one or more points in common. So if I look over at these lines to the side, I can see that these are parallel because no matter how far I trace up and down either line, I can see that these lines are never going to intersect, or in other words, they're never going to cross each other and share a point in common. With this in mind, we also know that these parallel lines have the same slope. In other words, in order for it to be true that these lines are never going to cross, if we actually count out the slopes of these graphs, I can actually see that they both have identical slope. Or in other words, they're both going over 2, up 1, over 2, up 1. Same thing with this second line, over 2, up 1, over 2, up 1. Right? And we see that because of these common slopes, this is exactly why these graphs never intersect. Perpendicular lines, however, are different. Perpendicular lines that do intersect, and in fact they intersect at a 90-degree angle. At a 90-degree angle. And because they intersect at a 90-degree angle, we actually find that they have the opposite reciprocal slope. And we want to talk about both of these two words, both opposite and also the word reciprocal. So first, opposite means that if one slope is positive, then that means that the other slope therefore must be negative. And keep in mind this works both ways, so if the first slope is negative, that means the opposite of that slope must be positive, and vice versa again. Reciprocal then means that the fraction is flipped. So when we put these two things together and we're talking about a perpendicular slope, what we actually mean then is that the fraction is flipped and it's changed from either positive to negative or negative to positive. So if we practice this to find the slope of a line parallel to this line, first we just need to identify that the slope of this line is our m value, or in other words it's this 2/3 value here. And since the slope of parallel lines are the same, this is pretty simple. The parallel slope is also simply going to be the same slope, or in other words, is going to be 2/3. Now, if we look down at the exact same equation, but now they're asking to find the slope of a line perpendicular to the following line, well, I need to do two things. First, I need to take the reciprocal, so I need to flip it. So instead of doing 2/3, I'm now doing 3/2. And we also need to take the opposite, so instead of it being positive, it's now a negative fraction, and this would now be our perpendicular slope. Now we can practice applying our definitions of parallel and perpendicular lines, and also parallel and perpendicular slopes. Here we're asked to write the equation in slope-intercept form of a line that meets the criteria, where it contains the point -5, 2, and it's parallel to the line y equals -1/2 x plus 5. Now, what we notice here is that we're very close to having a slope and a point. So first of all, we notice that we are given a point, which I can still call x1 and y1. So we can still use the point. What we really need is the slope, and that's what this piece of information over here is really asking us to find. It's asking us to find the slope of a line parallel to the line y equals -1/2 x. Now, I can see the slope of the line right here. Here's our m value, -1/2. And simply, since we're asking for a line that is parallel, I know that parallel slopes are the same, which means that the slope I want to use is also going to be the exact same slope of the line given, which is -1/2. So again, since they asked for a parallel slope, I'm asking for the exact same slope as the line given, because I know that parallel lines have this same slope. So, if we're going to write this equation, they asked for it in slope-intercept form, But we can still start with our simpler form of the point-slope form. So if I start with y minus y1 equals m times x minus x1, we can still start by setting the equation up in this form, and then we can put it into slope-intercept form in just a little bit. So plugging in, looks like our y1 value is the 2. So y minus 2 equals, the slope is again that negative 1/2, which was the same slope as the line given, times x minus negative 5, or in other words, x plus 5, because I am subtracting that negative 5 from the ordered pair, that x1 right up here. Now this is a good equation written in point-slope form, but I want slope-intercept form. And as a quick reminder, slope-intercept form is that form y equals mx plus b. So I can write that up here. We're really looking for y equals mx plus b. In other words, if I'm going to put this into slope-intercept form, I need to solve this equation for y. And there's really only two things I need to do. The first thing I note that I need to do is I need to distribute this negative 1/2 across the parentheses. So first I can go ahead and do this. And if I multiply the negative 1/2 across, I still have the y minus 2 equals negative 1/2 times x is just negative 1/2 x. And negative 1/2 times 5 is simply negative 5 over 2. Now at this point, the only thing I need to do is simply add the 2 to both sides to solve for y. So I can add 2 to both sides. And notice that this would then give me y equals negative 1/2 x minus 5 over 2 plus 2 over 1. Or in other words, if I want to, I could change this into a common denominator so I can add these fractions. Instead of writing 2 over 1, we can actually change this into 4 over 2. So I'll rewrite that over here to finish this problem up. What we really have then is y equals negative 1/2 x minus 5 over 2 plus 4 over 2, if I give that 2 over 1 a common denominator. So then if I combine our simplified terms, here's our final equation. Y equals negative 1/2 x minus 1/2. And that be our y equals mx plus b form. And I know that this is the correct form because it is solved for y. So as a quick review, we first identified that the slope of a parallel line is the same, so I kept the slope of negative 1/2 that was given to us. At this point we have slope and a point. I plugged the slope and the point into slope point form, which I see right here. I noticed that then I needed to solve for y in order to have it in the y equals mx plus b slope-intercept form. So I distributed the negative 1/2 to both terms, added the 2 to both sides, and then just simply found a common denominator between fractions, which was 2, and then added to get our simplified form. In this problem, we're given the point negative 1, negative 7, and we can once again call this the ordered pair x1, y1. X1 and y1. And once again, we're told that we want to have a line parallel to the line y equals 7/3 x plus 4. And since we recognize here that the 7/3 is the slope of this line because it is in y equals mx plus b, we want to have the same slope because parallel lines have the same slope. So we're also going to use the slope of 7/3. So now that we have a point and the slope, we can again just go back to slope point form. Or in other words, we can plug in our values into y minus y1 equals m times x minus x1. And again, even though we've asked for a slope-intercept form, which we remember to be y equals mx plus b, we recognize that we can simply plug into point-slope form and then convert this later on. So plugging in our values, I see that y minus our y1, which is negative 7, so subtracting a negative 7 means we're really adding 7. equals, our slope is the same as the slope of the line because we want a parallel line, so that's 7/3. 7/3 times x minus our x1, which is a -1, and subtracting a -1 means we're really adding 1. So this is the point-slope form, but we want slope-intercept form, or in other words, y equals mx plus b. So I need to solve this equation for y. So the first thing I'm going to do is distribute the 7/3 to both values here. So if we distribute, this gives me y plus 7 equals 7/3 times x. I can just leave it as 7/3 x, and 7/3 times 1 is just 7/3. So now to finish solving for y, I simply have to subtract the 7 to both sides of the equation. And this is going to simply give me that y equals 7/3 x plus 7/3 and minus 7. Now keep in mind that 7 can be written as 7/1. So if we're going to find the final form of this equation, what I really need is a common denominator to subtract these fractions, which means I can change this 7/1 into 21/3. Or in other words, y equals 7/3 x plus 7/3. And if I multiply top and the bottom by 3 on that 7/1, we get 21/3. And now we have a common denominator. So now we can subtract, giving us our final form of the equation, y equals 7/3 x minus 14/3. And since we've solved for y and simplified, this is now our slope-intercept form that they asked for. So here's a slightly different problem. We're still given a point, which I can still call x1, y1, so 4 will be x1 and 3 will be y1. But they're now asked for a line perpendicular to the line y equals -4/5 x. So if I notice that the slope given to us, since this is in slope-intercept form, is -4/5, the slope I want to use has to go on under two different changes. First, I need to do the reciprocal, and reciprocal tells me to flip the fraction. So instead of 4/5, I'm now going to do 5/4, and since this slope they gave us was negative, I'm actually going to do the opposite, which means I want a positive 5/4. So in other words, we're going to use positive 5/4 as the opposite reciprocal of -4/5. So now that we have the slope and the point, we can simply plug in to our slope point form like always, which is y minus y1 equals m times x minus x1. So plugging in, I can see that our y1 value is 3, so y minus 3 equals, our slope again is the opposite reciprocal of -4/5, which is a positive 5/4, times x minus our x1 value, which is 4, so x minus 4. So now we simply need to distribute through to simplify and solve for y, because again they are asking us to solve for slope-intercept form, so we remember that we are looking for y equals mx plus b as our final form of an answer. So distributing through, I still have the y minus 3 equals, and if I distribute 5/4 times x, it's just 5/4 x, and 5/4 times a -4 is -20/4. Now luckily though, this is actually a fraction we can simplify, because I know that 20/4 actually just simplifies down to a -5, so 5/4 x minus 5. And so now all we really need to do to finish this problem is add 3 to both sides, so plus 3, and this then gives us our final form of the equation, y equals 5/4 x, and then if I do the -5 plus 3, we find that minus 2. We'll finish this off, and since I've solved for y and simplified, this is our simplified form of slope-intercept. Here we see in a similar example, we're going to ask to find the equation in slope-intercept form, which we again remember is our y equals mx plus b form. But we're going to be able to use point-slope form yet again to find this, because we notice we are given a point, 6, negative 4, so 6 can be our x1 value, and negative 4 can be our y1 value. And again, we're asked to find a line perpendicular to the line y equals 2x plus 3. Now, since this equation y equals 2x plus 3 is solved for y, I know it's in slope-intercept form, and that means that this value multiplied by x, or in other words, 2, is the slope. Now, what we might be recognizing is that normally slope is in terms of rise over run, but keep in mind, if I want to, I could write this slope as 2 over 1. So we recognize that the slope of this equation is 2 over 1. Now, if I want to be perpendicular to the slope, though, I have to do two things. So first, if I take the original slope of 2 over 1, the first thing we have to do is take the reciprocal. So I need to flip it, making it 1 over 2. And then if it's the perpendicular slope, it needs to be the opposite reciprocal. So since the original slope is positive, that means we need to make our new slope a negative 1/2. And again, it doesn't really matter if we make the 1 or the 2 or really the whole fraction negative. We just recognize that one value is positive and one value is negative to make this slope of negative 1/2. So now that we have the slope and the point, we can simply plug this into our slope point form. Y minus y1 equals m times x minus x1. And so plugging in our y1 is a negative 4, so subtracting a negative 4 gives us y plus 4. Our slope, which is the opposite reciprocal of 2 over 1, is negative 1 over 2 times x, and then minus 6 for our x1 value. So once again, I need to put this into y equals mx plus b form. So the first thing I'm going to do is distribute the negative 1/2 in the process of solving for y, and that's going to give us still the y plus 4. And negative 1/2 times x is just negative 1/2 x. And negative 1/2 times negative 6, we're really just dividing by a negative 1/2. That's going to give a positive 6 over 2, or in other words, a positive 3. So we're almost done. Now to get our final form of the equation, I simply need to subtract 4 from both sides. And this is going to give us our final form, y equals negative 1/2 x minus 1 as our slope-intercept form of an equation that is perpendicular to the given line and goes to the given point. So at this point, there are 4 on-your-own problems I'd like you to try, and then we'll check back in on this during next class.